All right, so the first information we're going to look at in a mass spectrum is the molecular ion peak. Okay, I mentioned before that this is the most important information we can obtain from the mass spectrum because it tells you the molecular weight. Now, once you know the molecular weight, you can play around with it. Okay. Anyway, all right. So first of all, we're going to use this molecular ion peak to differentiate between pentane and pentene. Okay. I'm going to show you the mass spectrum. All right. Here's how it works. Let's bring you have a calculator, the scientific calculator, not on your phone. Use a scientific calculator. Be familiar with it, how to use it. Okay. Let's say we're going to use this calculator to calculate, to determine the mass of pentane and mass of pentene. All right. But before you do that, don't do it yet. Okay. If I ask you in general how you determine the mass of pentane, most students will do this. There are 5 carbons, so each carbon with about 12 atomic mass unit. So times 12 times 5, they are how many hydrogen times 1 and then combine. But no, we're not going to do it that way. Okay, I want you, your eyes are going to be eye training a little. I want you to look at this each compound in fragment. Okay, let's start with this carbon. Okay, so here I'm going to explain how it works here. So this carbon contains 3 hydrogen. This piece weighs 15 AMU, atomic mass unit. Carbon is 12, 3 hydrogen is the 1 each, right? So 12 plus 3 is 15. Next one we have CH2 right here. Look at it right here with me. Okay, CH2. So carbon is 12, 2 hydrogen is add 2, so you get 14. Next one, guess what? 14, 14, and then the last one on the right, you guess 15. Okay, all right, on your calculator, you're gonna go 15 plus 14 plus 14 plus 14 plus 15. Add them up, you're gonna get 72. All right, on pentene, do the same thing. Okay, I'll pause the video, do on your own first. I'm going to go right here. So we're going to have start with the CH3 15, CH2 14, CH2 14. Be careful this one C and H. Okay, this one 13, and on the right side right here, this is CH2, this one 14. Okay, for 15 plus 14 plus 14 plus 13 plus 14, you get 70. Here we go. That's how it works. Okay, all right. If I give you 2 mass spectra and I ask you to match to either pentane or pentene, what do? Well, you look at the molecular ion peak. Okay, this peak tells you the mass of the intact molecule, 70. This guy 70. This is pentene. Okay, the other one, of course, 72. That's pentane. All right, you can use mass spectrum to differentiate between compounds like this. Okay, all right, just check. So this one on your own. Okay, use a calculator to distinguish this pair using mass spectrometry. All right, mass spectrum basically. All right, I want you to calculate the mass on the left side using calculator. On the right side, do not use calculator. I want you to say something. Okay, all right, go with me. What's the mass of this piece right here? All right, 1, 2, 3. This one 14. Go to the right one. How much? This is CH. This is 13. Down here, same thing. 13. This one right here. This is 13, and this one also 13. All right, use calculator right here. So 14 plus 4, 13. You're gonna get to 66. Move on to the compound on the right side. Do not use calculator, please. Do not. I'll show you. Okay. Oxygen, start with oxygen. So by itself, it weighs 16. Okay, this piece right here, just this carbon, got 1 hydrogen. So 13, 13, 13, 13. What's the mass of this compound without using calculator? Well, only difference between these two, you're going to see just this piece right here at the top right here. This weight 14, this one weight 16. So the mass of the whole molecule should be 68. Add on to 2 AMU, atomic mass unit, on top of it. Okay. On B down here, do on your own. Okay. On the left one, benzene, weight 78. This one, nitrogen, only 1 atomic mass unit different than this carbon. And on 1, you get 79. Okay. A little tip in here, I'm going to talk about this on the next video. If there's an odd number of nitrogen, the mass is odd. We call this nitrogen rule. We'll talk about on the next video. Okay. All right. One more thing. So if you remember the base peak, the tallest peak, okay, the molecular ion peak is not always the base peak. For example, if the molecule is really long like this, so the molecular ion peak little right there, not a lot. So this is the pentane. Okay, it's a molecular, it's a radical cation. And the tallest peak, the base peak is actually 3 carbon carbocation. Okay, so whether or not a compounds have a base peak or the height depends on the stability, because Stephenson's rule, but we're not going to focus in this class. Okay, all right, that's a molecular weight. Next stop, we're going to go to nitrogen rule.